Alright, so picking up where we left off last time with if statements, we're going to talk today about loops. Now, loops are sort of the bread and butter main running time of a program because they're loops. They just loop over and over and over again until you tell them to stop. Now, in any programming language, there are three types of loops, and we're going to discuss each of them today along with some common applications. So those three kinds of loops are for loops, while loops, and do while loops. So let's start with for loops, since they're probably the most useful. So a for loop is formatted like this. So you start with for, and again, no semicolon on this because it's a conditional statement. All of these loops require conditional statements to tell them when to start, stop, and continue. So for loop takes three arguments. It takes a counter variable. This is the first argument you give it. So remember how I said ints are probably the most common variable types? It's because they are, and so you use them a lot in for loops when you just need to create a counter. So I create a variable I call I. This is the counter variable, and I initialize it to 0. I then set the running condition. So this loop is going to continue to run while I is less than some number or some variable. So I'm just going to call it 10. And then how or what you do with I. So I'm going to say I plus I equals I plus 1. And so that's your for loop. So I is going to start from 0. It's going to go up until I is not less than 10. So until it gets to 10. And then it's going to increment itself by 1 each time. Now you can shorten this by saying I plus equals 1, which is I equals I plus 1, or you can just say I plus plus. And you can increment I by any number you want or any variable you want. It all depends on your application. So a thing that for loops are really good for is printing out data from arrays. So if we take a note from our arrays lesson, I'm going to create an array, an integer array, and I'm going to call it R. And I'm going to make it 5 long. And that's going to equal 1, 2, 3, 4, 5. So there are 5 elements in this array. And in order to make sure I don't step out of bounds of the array, I'm going to make it less than 5. So I set it so that it goes through every element in the array. I make it so that I cannot be equal to, it only runs while it's less than the size of the array. So then I'm going to say standard, or I'm going to do the output thing. R, I, and there we go. Oh, I don't need that, right. So now if I run this, you can see it prints out 1, 2, 3, 4, 5. So it's printing out all the elements in the array. So I can make it so that this prints every other element in the array. So it prints 1, 3, 5. I can make it so that I starts from a different value. I can make it so that I only print, or so that I steps by multiples of 3. And the possibilities are really endless with what you can do with this. Again, it all depends on your application, but for loops are really good for stepping through n number of elements of things. So, as I demonstrated here, it's really good for stepping through with arrays. We can look at this in the debugger. So if I just run this and I start the debugger, so I can see the values. I can see what I starts as, and then I can see all the values of our array. And then I can step through. So I starts out as 1, and then I print out, where's my terminal? So I print out the first, or I print out the ith element of array, which in this case is 1, and R1 is 2. So it prints that. So it's back up here now. It checks to see if I is still less than 5. I now is 3, because we multiplied it by 3. It's still less than 5, so it steps in. So it prints out the ith element of array. It prints out 3, I equals 3. So if I step again, that should give us 4. And now it's going to try and increment I again. 3 times 3 is 9, which is not less than 5, so it should step out. It does, and that ends the loop. So that's how a for loop works. Now, the next kind of loop is the while loop, and the while loop is formatted like this. While, and then your conditional statement, and then your 2 curly brackets. Now, what you put in here is what makes, it's the statement that says, keep running this while this statement is true. Hence the while statement. So I can say, while I is less than 5. And I can create an integer I here. And I'll start it at 0. I want to print out array I. And I'm going to just block comment out this. There we go. And in this loop, I'm going to say I++, and I'm going to test this and run it. And as you can see, it does exactly the same thing that the for loop did. So this loop keeps running while I is less than 5. And on every step through the loop, I'll put a breakpoint here. Get rid of that breakpoint. So I starts out as, if I put a watch on it, there we go. So I starts out as 0. And then it prints out the 0th element of array, and then it increments I. And then it prints out the first element, increments I, second, third, fourth, until I equals 5, in which case it's no longer less than 5, so it steps out, and that ends the loop. So this while loop does exactly the same thing the for loop does, but you note that it has to be formatted in a different way. So all the loops can accomplish the exact same thing. It's just the situation in which you decide to use it and whichever one is more readable to you. Now, a lot of programs have something called a main loop, which is just the body of the program which runs over and over and over again. And a lot of times what they'll do is just, in order to make sure this loop keeps running, they'll put in a condition which is always true. So if you remember from the last lecture, while 1 equals 1 is something which is always true. And this loop will run forever and ever and ever and ever until it gets to a break. Break is the guaranteed way to break out of any loop. Now, a lot of people will tell you that break is not considered good programming practice, that you should format your loops in such a way that you never have to use a break. I say use break if you need to, because it's oftentimes very useful, and a lot of times there's really no good way to reformat a loop so that you don't need a break. So break gets you out of a loop. So I could put a condition in here that says if, that's my screen recorder, if I is greater than or equal to 5, move my mouse out of the way, break, curly brackets. And I'll put in the cout array thing again. And I'll increment I. So now if I run this, I was not declared in the scope. Whoops. I forgot to put in the integer I. There we are. So you can see it does exactly the same thing. Well, almost. So it prints out the array, and then it does something unexpected here. What is that unexpected behavior? Well, we can check that with the debugger. So if we run this, we can see what's going on. I didn't compile this. Let's try this again. Okay, so clearly code blocks isn't perfect. This is a weird bug. But you can see that I is incrementing, so it prints out. So if you watch I, 3, 4, 5, but see, and there's the issue. There is no fifth element, or there is no I equals 5 element of R. It only goes up to 4, so it's printing out an undefined value. So this brings up a good point about checking the flow of your program. This break isn't happening soon enough. It's allowing a value of greater than or equal to 5 to still be run. So I need to put this after that break so that that can't happen. And if I run this again, that solves the problem. So that's the while loop. Now, the last loop, and I'll just block comment this again. The last loop is very similar to the while loop. It's the do while loop. Now, again, like I just said about program flow, the while loop can never run. There are conditions in which the while loop will never run. If when it goes into the loop, the test condition is immediately false, it will never run the while loop. The do while loop, on the other hand, is guaranteed to run at least once. So if I go back to the while loop and just comment this out, or uncomment this and remove that section for a second, I'll make I equal to 5. So while I is less than or equal to 5, I want it to see out hello world. So, and I comment this out because that's not going to compile. So I run that. Right. While I is less than 5, not less than or equal to. There we go. You can see it never prints out hello world because it's never running. If we look at the debugger, we can see it starts here, and it just immediately skips it because I is not less than 5. The do while, on the other hand, has to run the statement at least once because it's going to go into the do while. It's going to run this statement. And then it's going to check the condition. So you can see it runs hello world from do while. So again, this really depends on the situation you're in. Do you want the loop to be run at least once, or do you want it to be able to fail right away? And it's, again, going to depend on the situation you're in. So these are the 3 different kinds of loops. Thing about the do while loop is that you should note that there is a semicolon at the end of the while statement. That's just how it's formatted. That kind of breaks the rule about semicolons, but that's how it is. So those are the 3 kinds of loops again. The for loop, the while loop, and the do while loop. The for loop is a counter. It's good at stepping through all values of something or making sure you step through at least certain values of something. And it runs as long as this statement is true. A while loop, again, runs in the same way. It runs while this is true. Actually, they all do that. But it's the order in which they check. These 2 check the condition at the top, and this one checks at the bottom. So these 2 can never run. This one will run at least once. All right, so let's go over some common errors that you might run into. Firstly, if I don't put a semicolon at the end of the do while, you can see expected semicolon before return. Easy fix there. While loop, if I put a semicolon there. Now, it doesn't complain, but if I make I 0, and I put in an I++ here, and I debug it, you'll see what happens. So by putting a semicolon at the end of the while loop, it never runs anything that's within the curly brackets. It just runs this condition over and over again. That is something that's called a busy loop, and you'll probably not use it given that this is a very introduction example into programming. Busy loops are useful for when there's something else, another bit of code that's modifying this variable, and you have to wait for it to change state, or you have to wait for it to get past a certain point. So this will never stop because it never increments I. It never runs into this. And if we look at the for loop, if I leave out a semicolon here, it's expected semicolon. If I don't initialize I, or if I don't tell it what I is, see, I was not declared in this scope. I can initialize I here. In fact, I can just create it. I don't have to initialize it. The for loop will initialize it for me. And then it runs. So you have to make sure that you give this some value. If I say here int I equals 1, and I don't put anything in there, or if I just say use I, I'll run this again, you will get warning statement has no effect, because it doesn't care about this variable. In fact, I can just leave this completely blank. So long as there's that semicolon there, as long as there's 2 semicolons, it's happy. So it needs a conditional check and an increment. It will run. So that is it for loops, and I will see you in the next lecture.